thank you very much for inviting us to come and down and talk to this, but I've kind of viewed this as a little bit of a double-edged sword to come and talk here. When Jim first said you're going to come and talk about upstream approaches to circular economy, I work in eco-design, so I thought, oh, how fantastic, I'll be able to talk about all these brilliant eco-design projects. And then he said, but it's got to be on a city level, and at that point my heart pretty much sank into my boots. So what I'm going to try and talk about is we've already heard that maybe Wales isn't performing quite as well in circular economy as perhaps it could do. So what I'm going to try and talk about is a little bit about what the Welsh Government have been doing to try to create the framework conditions which will mean that suddenly we'll come up and we'll overtake everybody else in terms of circular economy. So there are certain reasons why cities in Wales really would benefit from going more circular. They've been historically the workhorses of the UK economy. So they've built their economies on making stuff, and gradually those industries have kind of moved away, and they've left behind them the legacies of a very skilled workforce, but maybe with not the work to look at. They've left behind the legacy of the impacts of those industries that have been extracting and using stuff, and they've left behind a need for a new economy, which is coming from things like tourism, for example, where the impacts of day-to-day tourism are much more significant than we actually realise and see. So all of those impacts really need to be carefully managed, and they need to be carefully managed in a way that we think very sensibly about how all of them interact together. So we can take a more circular approach, and it will help us to tackle the issues we've got, so the significant environmental level, and particularly our lack of productivity as well. We are the least productive part of the UK. Our GVA is lower than everywhere else. So there's a benefit, though, for us at the moment, which is that we're slightly devolved. We're not wholly devolved, but we're slightly devolved. And in the devolvement settlement, we got responsibility for environmental and sustainable development. Now, I'm in polite company, so I won't use the term that I normally use for the kind of policy making that comes from that. But basically, we thumbed our nose at Westminster and said, we're going to do something really amazing. So we have a little secret weapon that I think is going to make all the difference in the future for us in the circular economy. Oh, and I've just skipped entirely past it. Here we go. So, in 2015, we became the first country in the world to actually enshrine sustainable development as law. It's now a statutory requirement for all of our public sector organisations to consider the well-being of future generations in all their activities. And there are we've got 7 well-being goals that everything should look at, and we've got 5 different ways of working. Now, within the 7 well-being goals, all of them have relevance to the circular economy, but 2 are particularly important. The area around the prosperous Wales, which is defined as an innovative, productive and low-carbon society, which uses resources efficiently and appropriately. And also a globally responsible Wales, which means that everything we do in Wales, we have to consider the global impact of. The ways of working are very much about embedding a systems approach. So we're looking at long-term, thinking about the long-term prospects. We're looking at preventing things, so looking at how we prevent unintended consequences. We're looking at integration and collaboration, so bringing people together to work together and involving local communities. So it's setting a really good agenda for us to think about how cities might develop and how basically Wales as a whole might develop. So that's at the national level. Now at the city level, we're also seeing changes in our cities. So in 2017, we got funding for 2 city deals. The first of the city deals was the Cardiff Capital Region city deal, followed by the Swansea city deal. More recently, the growth deal for North Wales has been approved, and now we're looking at what's going to happen around Powys and Mid Wales, and it's likely that there's going to be another growth deal that supports that. All of these growth deals actually post-date the wellbeing of future generations. They're all funded partially by Welsh Government, and they involve all of the local councils plus other stakeholders in the UK Government, which means that by having a statutory requirement for so many of the partners in that, actually they all have to grow in accordance with the prosperous Wales and in accordance with global responsibility. So it sets a framework again for us to start to think, okay, so these cities have got to change. This is the new driver for economic development in Wales, but it has to be resource efficient and responsible. So suddenly, the framework for circular economy is in place. City deals are really good as an opportunity as well for thinking about how to embed circularity, because they bring together partners with the same objectives. Everybody's pulling in the same direction. The partners are working together. They are bringing together both the city but the hinterlands as well. So actually the impacts are felt much further afield. So as soon as you start to introduce a more collaborative working across a city deal region, you increase the impact of what you're doing at the city level. So each of these areas are actually based on the local strengths. So they've already established what the local strengths are. Many of those are in line with the smart specialisation strategy for Wales as well. So they're related back to what we do in terms of smart specialisation. So we've got this setup where we've got particular things that are the focus, a growth where we have to be responsible and resource efficient, and the big economic drivers for innovation in the future. So why is a designer standing in front of you and talking about this? Well, design's been mentioned a few times today, and whenever it's been mentioned as product design. Design's a much broader field than that. Design's not just about products. Design thinking and ways of looking at things can be embedded into any industrial sector. We've been really lucky. So I'm from Eco Design Centre, and we've been really lucky because we're right back when we first started, way before, preceding the Wellbeing of Future Generations. Wales has always been quite progressive in the way it's looked at its waste policy. So the Towards Zero Waste strategy set out that we want it to be zero waste by 2050, and that we also wanted one planet's worth of resources by 2050. So we've been working towards that ever since. And the first thing that the Waste Department in Welsh Government determined was that you can't do that just by managing waste and recycling. So they've always had an approach where they've gone, okay, we need innovation, we need design, and we need support. And that's where Eco Design Centre came from. Between 2006 and 2015, we were directly funded from Welsh Government, and we were helping them to set a framework of policy, to help them to understand the baseline, and to help them to see where there are gaps and opportunities, and work with companies to develop demonstrators. So I'm going to come clean. Eco-designers are, and Eco Design Centre in particular, we are critical friends of the circular economy. We have certain views about the circular economy that say we don't think this is the answer to everything. And in particular, if it's not applied responsibly, one of those things is to prioritise the resource efficiency over lifetime impacts. So we're always slightly cautious. So what we did quite early on when Wales set out its desire to become more circular was to think about what is it that we can do that will ensure it's responsible? Where are there overlaps between eco-design and what circular economy does? So we found some mutual factors where we thought, okay, so if we build on these mutual factors and we make sure that by using eco-design principles, so using the same sorts of tools and methods, we can make sure that in becoming resource efficient, we don't move the burdens to somewhere else in the life cycle. Maybe we can make this work. So that's the strategy that we take. We say, okay, we're circular, but actually we're circular in a way that doesn't shift burden. So what have we done to try and help to prepare the ground? So we've developed a baseline, and this was done before kind of thinking about the circular economy, but actually provided a lot of the base work, the groundwork for Wales in the circular economy. We looked at industry, so we profiled what industry was actually doing in Wales. We looked at their propensity to take eco-design principles on, and we looked particularly as part of that at their propensity to become more resource efficient. So that feeds directly into the work that you need to do for a circular economy. So basically, Welsh Government don't have to throw away 9 years of eco-design research to become a circular economy. So we also looked at a particular area in resource efficiency for Wales around critical raw materials. So I think Rhys will talk a little bit more about this, but materials where there's a high economic dependency, where there's a big supply chain risk. So we started to map those for Wales as well. And they can help us to see how the industries that are involved in the city deals can actually become more effective in terms of the use of their critical raw materials, and can identify opportunities in terms of where they can do more resource efficient business as well. More recently, this is something that we're going to take to Welsh Government and basically say, we've done this for Scotland, we want to do it for Wales. So more recently, we've worked with Zero Waste Scotland, with our policy team as well, to think about, okay, where does design contribute to the major areas? We can do this at city level as well, so thinking about getting our stakeholders together. So this was a multi-stakeholder activity where we brought people together from the different sectors and looked at barriers and opportunities. So you're getting the involvement of the people who will be doing these kind of activities as well. So we're lobbying Welsh Government at the moment to do a similar project for them. We also have worked quite a lot in business model design, because earlier on, I think it was Cal that said technology can't answer everything, and it really can't. You know, no matter what you do, if you're making something, you're always going to be using resources. So really, you've got to think about how you use them effectively and think about how business models need to change. So we've developed a strategy through which we start with a systemic approach. So we say, okay, so where do we think this business could go? And that's our jump. So we create something that looks fully circular. So we make sure that most businesses in Wales are SMEs, and they don't have that much money, and they have quite a lot of worry about research and innovation. They don't necessarily access the same sorts of funding. So they have this kind of issue where they're thinking, okay, we can't really do that. So what we do is we go backwards and we say, okay, so this is the step, but it will set you on the path to this jump. So everything is linked so that there's a clear trajectory that companies can follow over time. So I mentioned that we have a global responsibility as well. So our most recent piece of work has been about addressing this global responsibility. So everything we do at city, at company level, impacts elsewhere as well. So the city is only one part of an ecosystem of any country. And one of the issues is we don't always know when we go for something more circular, say use of local resources and use of local wood in building, how that's going to impact on other ecosystems. So one of the things we're doing at the moment is working with the Natural Resources Wales to try to determine, okay, if we do this, what's going to be the impact over the rest of the Welsh ecosystems and the impact on the world as well. So we're starting to set frameworks to see what our global responsibility should really be. And the other thing is that if you're going to do these jumps, and you're going to do jumps that are really innovative, it's really great to work with a big bunch of people. So I feel like I'm really lucky. I work with Rhys and through Swansea University with a group of people for the Circular Economy Research and Innovation Group, which brings together academics from every university across Wales to look at what's really new, what's really cutting edge. And we think those sorts of things are laying a platform for us to be able to suddenly start accessing that funding and start jumping up those tables that we saw earlier. So I've done the boring bit, and now Rhys is getting to do the really exciting bit and show you some really nice pictures of the stuff that he does that actually puts it into practice.
Thank you, Katie. Right, I'll fly through this as fast as I possibly can for the sake of time. But first of all, thank you for the invitation to be here. It's been a pleasure to meet so many people. So yes, I'm Rhys Charles and I work at Swansea University at Specific. Won't bother elaborating on the acronym. The main function of Specific, when it was first established about 7-8 years ago, was to develop this buildings as power stations concept. Now, to get there, we've gone on a long journey and we've learned some things about how to engage partners and how to work together to develop an idea from the very beginning through to commercialization and deployment. So what I'm going to focus on now is the things that we work on that I think lend themselves to circular cities, and also maybe some of the strategies for working that could help anybody involved in this sort of thing. Okay. I was going to spend some time talking about the context that we're working in around circular economy, but that's been covered by other people, and because we're running short of time, we'll just fly through that. The only thing I want to say about this is that because of linear economic models and the fact that we're consuming raw materials, including fossil fuels for energy, and generating waste, and very inefficiently recovering anything at the end, then we have this issue where economic development correlates with a very linear trend to the use of resources. The same is true for the use of energy. As you become economically developed, you consume more and more and more energy. And this graph shows us a problem in that, if we just flick through this quickly, as countries become economically developed, they tend to move according to this trend, okay? We want countries to become economically developed and end up on this side of the blue line because they've got a good standard of living. But what these dashed lines show us is the Earth's average biocapacity to sustain each of us, which is obviously shrinking as population grows. Now, because of linear economic models, we're moving this way. So we need to decouple growth from the consumption of resources, and that's exactly what circular economy does. And it's going to help developed countries to get down into a sustainable place and allow less developed countries to improve their standards of living and grow without compromising the future of our species on the planet. The other thing is that to achieve this green state of affairs for the world, we're going to need technology, and a lot of that is green technology. And unfortunately, for most of those technologies, we need technology metals, which are critical, and future supply may be at risk. So this is sort of the context we're innovating within, okay? So what do we need? We need, first of all, wide-scale deployment of affordable and sustainable green energy technologies. The technologies, and by that I mean not just the products, but the whole life cycle and all the enabling processes have got to be optimized for circular economy. This means maximum retention of material resources and take back of products at end of life or end of use, whichever way you want to look at it. We definitely need to avoid contributing further to the increasing scale of the global wheat problem. Right? This is a global disaster, the production of wheat, and we need to make sure that going forward, any electronics we make don't contribute further to this problem. We also need to eliminate our susceptibility to global resource security issues so that we can continue to deploy these technologies. We need to eliminate materials that pose risks to the environment and human health. And of course, we want to create jobs through the growth of a sustainable domestic industry. Katie talked about this, so we'll skip it. So what Specific does, it's an academic industrial consortium that have the shared vision of functionalizing the building envelope with innovative thin film and functional coating-based technologies so that every building can generate its own energy from the sun, store it somehow, whether that's thermal energy or electrical energy, and then release it when it's needed. So in order to do this, early doors, we partnered up with some very important strategic partners, Tata Steel being one, Axo Nobel, at the time it was BASF, but it's Axo Nobel now because they've bought the chemical branch, and NSG Pilkington, the biggest glass firm in the world. So they all have a vested interest in this, and of course our colleagues down in Cardiff University have been involved all along the way. As we've gone along as well, we've identified other partners with key knowledge in areas that we don't have. So now we have another 30 academic partners on board to do with technology development, also supply chain partners, and of course end users, because you need feedback from them. And Specific is now well on the way to developing all sorts of innovative and new technologies to achieve this. So as part of this Buildings as Power Stations, or BAPS vision, one of the things that we need to do is functionalize the outside of buildings with PV to generate electricity. So that might be glass type buildings like this, so it means functionalizing windows, or it might be big steel constructions like your IKEA and that sort of thing. For this purpose, the partners want to develop third generation photovoltaics or printable photovoltaics. These haven't quite hit the market. I'll explain a little bit more about what that is and the difference with normal PV in a minute. And to achieve this then, the Specific setup is thus. So first of all, we have fundamental scientific research in the lab, looking at materials, developing concepts, and different kinds of devices. What we do then is, once we've settled on a material set or a technology, we run off smaller prototype modules. We use those to prove the concept. And then we also have a pilot manufacturing line. So we can take these lab-based devices and start looking at scale-up and production. And this is very important because it de-risks adoption of the technology for our partners and helps accelerate technologies through TRL levels. just because you can make it in the lab doesn't mean you can manufacture it. So here's where we look at how you manufacture it and overcoming all those scale-up problems. Then what we do is we take those technologies, we integrate them into other systems and see how they run. We integrate them into buildings, and we've got to the point now we've actually got some full-scale demonstrator buildings, like this one here. The active buildings, we call our demonstrators, yeah? So we've done a couple now, but the flagship one is been, to date, the active classroom located on our Bay campus. Now this is a really important building for us because not only does it give all our partners the opportunity to demonstrate their technologies, it allows us to show that a building as power station is a real thing that can work. We use this every day for teaching and all sorts of things. And it also allows us to learn the best way to integrate technologies together for the best outcome and how to manage those technologies, okay? So BIPVCo, one of our partners, they make these roof tiles with integrated PV using SIGs, so that's all on the roof. Solar Plants, another one of our partners, they've provided us with these Aqueon aqueous hybrid ion batteries that do all the electricity storage. The building itself is modular, which lends itself to circular economy. So we work with this company, Matrix, who's developed these new panels, basically, that you use in the walls, floor, and roof. It's basically a steel frame and some insulation and some boards. But this is great because these click together like Lego, so in theory, you can click it all apart and reuse the panels somewhere else, or even rebuild the building somewhere else if you wanted to. We'll see how well that works if ever we try and tear it down. Because then we want to rely on electrical energy, we've developed in specific this novel underfloor heating technology, relies on carbon coating printed onto some of Tata's Prisma steel. And what we can do then is by drawing electricity from our battery, heat the teaching space. We have transpired solar thermal collectors, which is a Tata product on the side, which work with a heat pump to draw warm air into the building, which reduces our demand for electricity to heat the building. And we're also working on new stationary storage media for thermal energy. So once we had the active office, this demonstrating the principle really worked well. You can see there the Secretary of State for Wales, Alan Cairns, showed up. And so, of course, the Vice Chancellor did too when he heard he was coming. But Innovate UK was so happy with all this and the way we were moving along with our partners that they gave us another £800,000 to build another one. But this next one had a very specific purpose, okay? We needed an active building that was repeatable, not like this one, that we could make commercially available as soon as possible and think about starting to roll out across the place. So we built one of those. There it is, the active office. So we're 2 stories now, slightly different construction strategy. A lot of this is constructed off-site, then comes on looking like containers, but then it all clicks together. Different technologies on this building too, some of them. We still have the PV. We've gone for lithium-ion batteries this time. We're also looking at what role an active building can play in the wide green energy picture. So we're looking at electrical vehicle charging and also drawing energy from the vehicles. And we have these new technologies on here, these PVT tubes. So these tubes have got solar panels in them for generating electricity, but they also collect thermal energy, which we store in the thermal storage unit. We couple that with an air source heat pump as well, and what we've got is an active office, which again, people are actually working in. So we're learning now more about the environment and getting feedback on that. All this has led to the award of 36 million quid from the Treasury to create a national centre to accelerate market adoption and nucleate a revolution in smart active buildings across the country. So that's what the centre will in theory look like, but although that will be in Swansea, what we're doing is hooking up with a whole range of partners. This just shows that actually what ABC is doing is sits in the middle of a couple of areas of the industry strategy. So ABC's got some important deliverables, right? First of all, it needs to create an active, a critical mass of active buildings. Get enough of them out there that people are interested and want to adopt this, okay? We want to look at as well how we integrate these buildings with the Internet of Things, building management systems, and we want to also look at how active buildings can act as energy positive agents, so help with demand side response and the transition of the current grid to a more renewable grid where energy storage is going to be important. we need to aggregate active buildings at national scale, so we need to create the right market conditions, business models and that sort of thing. So that's all learning that will come out of the project. And we need to adapt the active buildings technology portfolio so that not only can we build new buildings at their own power stations, but retrofit existing ones. Most of the buildings we'll have in 2050 are already here, so we need to figure out how to convert those as well. So again, we identify partners with all the key knowledge, competencies, and also industrial partners who really, you can almost consider this like a demand-driven project, if you will, because all of these are vested interest and a business interest in seeing this happen. So it's a huge project with lots of partners. Never mind that. Okay, the circular economy bit. Now this is the bit I work on. So specifically with the PV, my background is in waste management. My NGD looked at how we can deal better with electronic waste within the context of circular economy. So what I do now is I work with Specific to try and develop technologies that are optimized for circular economy early days. It's no good developing a technology and then try and lever it into circular economy. The earlier stage you do that, the more successful it will be. So with 3G PV, that's what we're trying to do. Now it's different from silicon PV, okay? This is silicon PV. This dominates the global market. It's highly efficient, it's got great stability, but the devices are rigid and heavy. Silicon itself now as well is on the EU critical materials list. And because this stuff's heavy, you can't stick it on buildings that were never engineered to take the mass. It also needs to be put on a south-facing roof and angled appropriately, yeah? After that, now we're seeing the emergence of second generation thin film PV. So that's amorphous silicon, CAD-TEL and SIGs. So this stuff's bendy, it's lighter weight, it's not quite so efficient, but it's a lot cheaper. So levelized cost of energy is competitive. It's got lower energy payback times, lower emissions associated with electricity generation, all good stuff for circular economy. Problem is it still uses toxic and critical materials, so that's why we're working on third generation PV. So this includes perovskite PV, which is yet to be commercialized, organic photovoltaics and dye cells as well. So these are thin film devices which we try and make from earth abundant materials. Now they can be opaque, we can tune the color, so there's a lot of aesthetic possibilities. Key thing though is that these things perform really well in diffuse light conditions. So indoors they work a lot better than traditional PV. It also means if you haven't got a south facing roof, you can stick it on the walls, you can stick it anywhere. It's good stuff. But it still needs to be optimized for circular economy. Now, because we can make this stuff with roll-to-roll production, where essentially you can take a coil of your substrate, whether that's plastic, steel, whatever, you run it then through a series of deposition and curing processes. So at the end, you've got your substrate, and then you've got a thin film device made of all these different functional layers. We like that because you can be super efficient in putting your materials down with solution deposition. So that's good from a circular economy point of view. But there are other problems as well. So what we're truly trying to do, we've all seen this before, this is the circular economy. Stuff comes in, gets manufactured, ends up with the user, and we want to retain it in the tightest circles as long as possible. But the other thing the project does, in the interest of minimizing our consumption of primary raw materials and leakage of materials from the system, is look at how we integrate this technology with a wider circular economy. Where can we source secondary raw materials through industrial symbiosis? And in our own processes where we generate waste that we can't reutilize, who else can use it? How can we add value that way? And of course, we want to look at sourcing biological materials as much as we can. So doing this for this technology actually has a really good commercial advantage, right? Because the commercial viability of any PV technology is based on a levelized cost of energy, yeah? What is the price per kilowatt hour? And all the companies have been pursuing this strategy. It's the right balance of the efficiency of the device, its cost, and its lifetime. So by cycling materials and components, we can actually bring the costs down for making this stuff, especially over successive product generations. If we can make PV that we can maintain, upgrade, repair, that improves its lifetime. And if we can retain embodied environmental costs of the materials, again, we have a greener product with greener electricity generation. So overall, doing this will allow these technologies to be more competitive with alternative renewable technologies in a very competitive global market where the consumer is becoming increasingly environmentally aware. Now, optimizing all these loops on our own is impossible. Nobody understands the whole picture, right? And this involves the entire life cycle. So not only is it multidisciplinary, it's cross-sector. So what we've tried to do is identify partners working on each of these different parts and partnered up with them in the accepted project, okay? And by working with these guys who we've identified who have key competencies and fill the knowledge gaps we don't have, hopefully we can get there. So there are a few project deliverables, but those are quite specific and probably not all that relevant. One thing I do want to say about this technology, though, that's very important, in the interest of avoiding the recycling loop and remaining within the remanufacturing centre, because we can build these devices in stacks with solution deposition, the solvent used to deposit one layer won't dissolve the other. So that means with an orthogonal solvent approach, we can work backwards and selectively dissolve away all the layers, keep the major environmentally important components like the substrates, that sort of thing, and then remanufacture them by putting all these layers back down. I think we're short of time, so I'll kind of wrap it up there. All I wanted to do as well was point out this paper I came across, which I think a lot of people here be interested in. This isn't ours or anything, but it contrasts the system conditions for the transition to circular economy in England, Ireland, Scotland and Wales. And apart from that, thank you very much. I'll take any questions now.